So at the start of 5.3, what I like to do is just let's consider a couple situations to help build what we're going to see in this particular section. Here what I have is I have a polynomial, and again it's a nice smooth curve with 1, 2 turns. So I would expect this polynomial to be a cubic at the very least. Alright, so something of ax cubed plus bx squared plus cx plus d. Alright, however, if we use the theory that we've been using so far, right, in 5.2 we learned if we can find this 0 right here and get, a factor of x minus c and divide that, what we end up with is a quotient, right, x minus c times something in, some x squared polynomial, and the other two remaining zeros, because we have a degree 3 polynomial, would have to be from this guy here. However, when we look at the graph, we can only see that there's only one x-intercept, and we're expecting 3 answers, and the one intercept only gives us the 1. So what about these other 2 that we're supposedly expecting? And the fact that we can't see that means that they are complex number solutions, meaning that they are some form of a plus bi. So that is basically visually what happens when some polynomial has a complex solution. You will actually not see them crossing the x-axis. And so that kind of bodes well with regard to our theory, as we'll get here, right? Because of degree 3, we should be able to find another c1 and c2, multiply it up to the x minus c that we actually do see, and that combination of factors should create this polynomial here, right, with some leading coefficient out in front. So the fact that in 5.2 when we were doing this, we were actually crossing the x-axis pretty much the number of times I would expect. Maybe there was some multiplicity involved, but we can at least account for all the zeros by looking at the intercepts. But as we dig deeper, we'll find that some polynomials actually do not cross the x-axis, but they still have zeros. It's just that their zeros are complex, which is why we don't see them in our real graph. And then this one's even tougher, right? When we look at this one, again, it's a polynomial because it's a nice smooth curve, but it's not crossing the x-axis at all. And because of the number of turns that I see, right, 1, 2, 3, I would expect this to be of degree 4, right? So some a to the x fourth plus bx cubed plus some cx squared dx plus f. And because we don't see where it's, we're expecting, again, 4 zeros, but I don't see where it's crossing the x-axis. It's never crossing the x-axis. So again, what that tells me about these 4 zeros is that they're all complex. They're all the form a plus bi. And then that really presents a large problem, especially for the way we've been doing these things, because if I know, where to start in terms of dividing, I start dividing this and I start breaking the polynomial down. But if I don't see any x-intercepts, the complex numbers are pretty, this is a hard enough thing to do already. How do I figure out, what form of a plus bi do I start dividing by to find the zeros of this polynomial? And that gets a little tricky. So that's kind of where we're at. We're expanding the possibility. So far in 5.2, we're talking real zeros, which we know there's 2 types. There's the nice ones that are rational, and then there's the tougher ones that are irrational. But what's happening in 5.3 is not only considering those 2, but we are also considering situations where the zeros aren't observable. We don't see an x-intercept, which means that they are actually occurring in the complex number system. So that is where we are headed. So that's an overview. We'll do some theory, and then we'll do some problems, and just basically you'll find it's the same thing we were doing in 5.2. It's just that some of our solutions now come from everywhere, rational, irrational, and the complex number system. So more on that in a moment when we do some more videos.